And if we want to make new tests for other maps, should we get about finding the expected answer? If you want to create your own tests for other maps that are not supported in the public unit test, then you have to yes, you have to write your own unit test functionality, and you have to basically think about how to generate random data and query them. What is the actual tutorial? Yes. So the actual tutorial, we're gonna cover two things. One, we're gonna first do a demo together on how to resolve Git conflicts with your teammates. So working on milestone 1 and future milestones, you will definitely face a problem where you and your teammate basically change the same file. And when you're trying to push, you forgot to pull beforehand. So it will tell you that I can't push because there are changes on the remote repository that are not on the local one. So how can we resolve these ones? And the second part of the tutorial will basically talk about code style and how you improve the readability of your code. So I'll start the demo now, and you can stop me basically anytime if there is anything I'm not clear. Okay, so Professor Betz and I basically decided to do the milestone together, and we basically split the functions. The tutorial runs from 3 to 4 and then repeats. Yes, exactly. So we'll try to finish before 4, and then from 4 to 5, we'll repeat the same material. Yes. Okay. So yeah, Professor Betz basically and I decided to do the milestone together, and we created a group for us, like similar to the ECE297 init that you guys have, and we split the functions between each other. Basically, we agreed that each one of us will work on a separate file so that we do not interfere with the other's work. But basically, Professor Betz, there was some miscommunication, and basically Professor Betz changed m1.cpp, and he pushed a code that basically implements the find street segments of intersections function. But this code was basically the naive implementation that passes functionality, but it doesn't pass performance. In the meantime, I was also working on this function itself, but I was trying to implement the faster implementation. So if we do a git log right now, you will see that there are only commits that are related to my changes. So Abed Yassin, both of them are my changes. However, Professor Betz had already pushed his code to the remote repository, and I didn't pull. There is a way to basically see this. If you do a git fetch, what the git fetch basically does, it pulls the metadata of the remote repository. So it will tell you what changed in the remote repository without actually merging those changes to the local one. And then if you do a git log origin master, origin is the remote repository, and the master is the current branch that we are at. So it will tell you that the log history, the one for the one that is on the remote. So you can see that the origin master is currently at this commit made by Professor Betz, and it says that he implemented the find street segments of intersection, and it passes functionality but fails performance. Okay, while our current local repository headmaster is still at this commit. So these changes are still not merged with my local ones. Now let's say that I go to Vim to m1.cpp and I want to basically implement the function. So find street segments of intersection. This function is empty, but I had already implemented the data structure, which is the vector of vectors. We talked about it last week. So return intersection street segments of the intersection ID I'm given. Okay. So the first thing I have to make sure is that the code compiles without any errors. Oops, oh, I'm not in the correct directory. So CD 297, word, method, okay. And let's make. Wait, what does git fetch do? So what git fetch does, it is similar to git pull. It basically gets everything or brings everything or all the data about the remote repository to your local repository. However, what it doesn't do is that it doesn't merge those changes. So basically, what git fetch does, you can think of it that it just gets you the metadata of the repository. What it will tell you that what changed on the remote, but it will not reflect those changes on your local one. Does that make sense? On the other hand, git pull, basically it gets those data and it also merges them with your local one. So it will sync basically your local repository with the remote repository. But git fetch will not do that. Is it clear or no? So if I opened a file, it would be the one on the local. Yes, it will not. You will not see the changes on that file if there are any changes on the remote. You will only see the change, your local copy of the work. So it's basically the first step of git pull. It will just pulls the information about the remote, but it will not reflect the changes. Okay, so it's only for commands like git log. Yeah, if you only want to see information about the remote repository without actually getting the code. Like let's say that you currently have some code that you don't want to stash, for example, or you don't want to basically get rid of. So you can just pull the information and look if there are any changes. It's rare to use. It's just for this case, I'm showing you one example where we use it. Yeah, okay. So after we compile, basically, we want to make sure that the test now passes performance and functionality. So first of all, let's print all the test names because I only want to test that specific test, right? The intersection test. So if you do ECE297 exercise dash list testers, it will list all the test names that the tested executable will run. In this case, I want to only run the func intersection test and perf intersection test. So if you remember from our previous tutorial, we can tell the tested executable to do run underscore tester and provide it with a pattern, which is in this case star intersection star plus quotation. What this will do, it will only run the test names that have in the word intersection in them. So in this case, func intersection and perf intersection. And yeah, you can see here the following two tester will be run. So let's wait for them to run. In the meantime, let's see what changes we've done to the repository. So we can do this using git status. It will tell you that we have modified m1.cpp, and we have also modified the example test, which is because of the exercise that I was just showing to you. Is there a command to see what functions each tester run? No, for that you basically have to go to the actual CPP file and see what functions to run. But you can infer them from the name. So for example, for this time test, it's basically, it will test all the functions that are related to length, travel time, area, etc. Intersection, it will basically test all the functions that are related to querying things for them from the intersection. For example, find adjacent intersections, find street segments of intersections, etc. Does that make sense? No problem. Okay, so basically it tells us that it finished the test with passing functionality, both functionality and performance, which is good. So now I want to basically push the changes of my local repository to the remote one, so my teammates can see, can basically see that the function has already been implemented and it passes everything. So the first thing is that what we want to do is add all the files that we've changed. So git add libstreetmap source m1.cpp git add libstreetmap tests example test.cpp git add func. These files haven't been pushed to the repository basically. And git add, last one is live street mag test unit test. Okay, so if we do a git status, then the colors will change to green, which means that we've already done a git add, but we haven't committed yet. So git commit dash n implemented, give it a basically meaningful commit message. So implemented find speed segments of intersections, passes, functionality, and performance. Okay. Also added infrastructure for unit test. Because we have added like new files that really are related to how to run the unit tests locally. So this is basically tells the teammates that what changes overall we've done. Okay, so it looks like it committed properly. Now let's do a git push. Remember that we haven't pulled the code yet. Like let's say that I forgot to pull. So let's see what happened. It will tell me to type in my password. And it says that it's rejected. The error says failed to push some refs to whatever CD000, which is basically the Professor Bez and my group. And if you read the hints, basically these hints are important. It tells you, this hint tells you basically updates were rejected because the tip of your current branch is behind its remote counterpart, which means that there are changes on the remote repository that we haven't actually merged with the local one before pushing our new changes. So it tells you that you should do a git pull first before pushing again. So let's attempt to do a git pull. And remember to use -r option with git pull, which tells basically git to try and automatically resolve any conflicts that might happen. Okay. So if there are multiple changes on multiple files that I did and my teammates did as well, it will try to automatically resolve them. It will not complain about them. The only thing this will fail is in the case where we are both changing the same file and it cannot decide which changes to keep. And in fact, actually, we are both changing, in this case, the same function in the same file. So it will definitely fail. So let's see what will happen. Yeah. So if you read basically the output, these are a lot of output, but if you actually read it line by line, it all makes sense. So it's saying that I'm trying to apply my current commit, which is implemented finds three segments of intersection, passes functionality and performance, which is the one we've just done. And it says that I've changed m1.cpp. Then if you keep going down, it says that I'm trying to auto-merge m1.cpp, but there is a conflict I could not do that. So it says fail to merge in the changes because the remote changes and the local changes both change m1.cpp. I have a simple solution. You just delete prof.best version by using git push -f. Yes, but as again, you will definitely face this problem. Like not all students do know git push -f, and it's actually dangerous to do a git push -f because Professor Betch changes might actually include more changes than what you want to delete. Okay. So let's say Professor Betch changes implemented three functions. One of them is the naive implementation of find street segment of intersection. So if you do git push -f, yes, you can do that again. Yeah, but we've already committed. With commit, git stash will not do anything. Git stash only works on the changes that haven't been committed yet. So here we are trying to demo a specific scenario, which is we already committed. We are trying to push, but there are changes on the remote that are not on here. So I don't recommend using git push -f because we don't know the changes that actually might conflict with ours. They might be other changes. So you have to pull them to your local one and sync it. Okay, so basically it tells you that fail to merge the changes. And if you continue reading, it says try to resolve all the conflicts manually, then add the changes or the manual changes, and then do this command, git rebase -- continue. Rebase is basically a merge command. And if what git pull dash r, it will basically implement what git pull dash r do is that it implements the git rebase as well. Git pull and then git rebase. So it tells us that once we finish resolving all the conflicts manually, do a git rebase dash dash continue to tell the repository that, okay, we've resolved everything. Now I'm ready to push again. So how do we resolve the conflicts? First, let's do a git status. Git status basically tells us where the conflicts are. Under unmerged paths, it tells us that we both modified m1.cpp. So if there are multiple files under this, basically it means that there are multiple conflicts in multiple files. But in this case, there is only conflicts in m1.cpp. So we go to m1.cpp and open it again. And the way we look for conflicts is we do search for this pattern. Greater than, or less than 3 times or more. Okay. And it will immediately jump to where the conflicts are. So you will see some weird symbol like this. Less than, whatever, and then head. Some code under this. There are then equal signs, some code under this, and then there are greater than. So let's see what this means. Under less than head, these are the changes that are on the remote repository, okay? Under equal, but before the greater than, these are the changes that are local, the ones that I made. So basically, when we're trying to resolve the conflicts, we have to choose one of them or both of them and delete the, if we choose one of them, then we have to delete the other. So in this case, I know that Professor Betts changes will only pass per functionality, but will not pass performance. So basically, I do not need those, and I can delete everything under here. Okay. Now, because these symbols do not compile with G++, you also have to delete them. So we delete this line, and last we delete this line. Okay. Let's search if there are other conflicts that we haven't resolved. We also search for the same pattern. Okay, it says pattern not found, so it doesn't look like we have any other conflicts. So before continuing, make sure that it's still compiled. Okay, looks like it still compiles. And now we do what the basically hint told us. So it says once you resolve the conflicts, do a git add and then git rebase dash continue. So let's do that. Git add libstreetmap source m1.cpp, and then we say git rebase dash continue. Okay. So now it was able to apply our changes. Now, if you do a git log, it says that origin master, which is the remote one, is still at Professor Betts change, but the local one we were able to basically pull the changes and apply our changes on top of them. So what remains now is to do a git push, and it should basically push the changes again to the remote repository. And if we do a git log right now again, so both the local repository and the remote one are at the latest change, which is the one that we've just done. Any questions on this? This is basically how you resolve the conflicts, and I'm pretty sure basically some of you will face these problems either in the project or later on in your career when you work with bigger teams. Git rebase is like commit. No, git rebase is like, it's a merging command. It basically tells the repository that I want to merge this, like this change with this change, and they are on two different repositories, basically the local repository and the remote repository. How did you go from Git to the page in terminal? Oh, I'm using something called tmux. So this is not related to Git. Tmux is basically a command line on top of the actual command line that lets you split screen. So basically, there are certain keys on the keyboard that you can click to switch between the key windows, and you can also add another screen if you want. So if you want to read, if you want to know more about it, you can read about Tmux online. There are a lot of resources about it. Go. You have a handout or website with a list of Git commands that you like. Uh, Not really, but there is basically there is a documentation, a popular documentation online that I usually use. So Git documentation, which is this one, I think. Let me see. I know from the this one, the fast version control. So here it has everything from the basics of Git to the full documentation. If you are interested to know more about Git. Oh my God, I can type. Do you have a hand? Yeah, I think that's okay. Do you ever use Git for things that are not code? Yes, I use Git a lot to basically back up all my stuff. Especially like, for example, I'm writing papers, documents, and I want to save the history of those documents. So I usually use Git for that. So any other questions on the demo before we move on to the code style? Sounds good. Then I can basically start the slides here. Does Git rebase commit non-conflicting changes? Yes, basically Git rebase is what it does is that it tries to automatically resolve the conflicts. Not commit, it will basically try to merge the changes on the remote and the local one if they do not conflict with each other, okay? So let's say that the changes are in different files, it will automatically merge them. That's fine. But if the changes are in the same file and in the same function in this case, which is much worse, then it will tell you that I couldn't merge them. Does that make sense? Sounds good. Let me just pull up something here. No problem. Okay, so the next part, basically, we're going to talk about code style. Why is code style important, and what are some of the aspects that you should look for when trying to improve your code style or the readability of your code? So, why is code style important? Basically, the code that you write is only written once, right? But it might be read by several people if there are like multiple people working on the same project. And it might also be modified by your teammates or by other people. And often we cannot reach the original author again to understand what is happening in the code. So for example, let's say that you are working for a big company like, let's say, Facebook. You've made some changes to the code base, and then in your career, you basically change jobs, so you're not working at Facebook anymore. But some other person, some other employee basically is trying to work or extend the project that you were working on. So basically using the same code. So obviously they can't reach back to you because you're not working at the company anymore. And all they can do is try to read the code if they don't understand it, which is very bug prone and error prone because only the original author knows exactly what is happening if the code is not readable. And that's the motivation behind code style. In code style, we try to simplify the code base in a way that makes it readable and understandable by anyone other than the original author him or herself. So it helps us to reuse the code. It minimizes the chances or the probability of getting bugs when trying to change the code. And today, we're going to basically talk about the main guiding principle to code style and some of the aspects that, again, we should look for to improve our code style. So the main guiding principle, as the motivation actually implied, is one, we should try and reduce the cognitive load. What do you mean by this? Basically, when trying to program a large algorithm, it requires understanding a lot of details. However, according to a law called Miller's law, the human mind can only keep track of, on average, 7 changes or 7 objects at a time. Okay. What we mean by this is that, like, if the code go beyond 7 lines on average, it's hard. It starts to be hard to keep track of the function, for example. And that's the motivation behind reduced cognitive load. Try to, for example, move certain parts of the code to separate functions that you can just call with one line, so that you can minimize the things that you are looking at at a certain point in time. And the second guiding principle is that we should always try to explain why we are doing this, not just write the code. So, and this is through the use of comments. Basically, with comments, we can say that, okay, this section of the code is trying to implement this algorithm because we need it in this case, in that case. Or, for example, this data structure will be used later on for this specific reason. And we're going to see some examples on how to do this. Okay. So how do we, first of all, let's talk about how to reduce the cognitive load. How do we reduce the length of the function in general? So the first guiding principle, or the first aspect that you should look for, especially when coding milestone 1 or future milestones, is that if a function is longer than around 10 lines, then it's not a good code style. Okay. Don't say, for example, or like, don't think that you will just add 2 more lines and then that's it. Sometimes you keep saying this and repeating the same thing. I'll just add 2 more lines every time, until you eventually look at the function and it's actually out of your hand anymore. You don't understand what's happening. It's very long. So once you go beyond 10 lines, try to think of ways where you can reduce the function length. Always remember that shorter is better. How you can improve the length of the function? For example, try to move parts of your code or reorganize parts of your code to different functions, and try to remove any unnecessary variables that they are not adding anything to the clarity of the function, for example. Again, we're going to see some examples about this. Okay. Second thing that improves the readability of your code is the naming. Naming variables and functions is very important. They should be as descriptive as possible to what they contain. Okay, so the variables should basically, the variable name should imply what this variable is used for. The function name should imply what this function implements. And the second part is temporary variables. Again, if there are temporary variables that are not used, try to minimize them. The other thing is try to minimize the scope where you are declaring the variables. So don't declare the variables right at the top of your code. So for example, try to minimize the global variables, amount of global variables to use. Only declare the variables where you are actually need to use them. Now, obviously, if the scope of the variable is too big, then it's better to actually have it as a global variable. But usually for local variables that you're only using in functions or like in certain clauses of an if statement, try to declare them in that if statement or in that function itself. Okay, so we're gonna now go into an example and try to enhance the code. But first, I'm gonna basically ask you a question. What do you think the code? What do you think of the code style of this code, the one that you see on the screen? Is it like poor, average, or good? I'm just basically gonna take your opinion, and I'll tell you what my opinion later on. This is a very subjective question, so you don't have to all agree on the same answer. Okay, so it's rather long. It's bad. Not sure what all of those doubles do. Okay, no comments, but seems simple. Okay, yeah, looks good. I'll give you around like 10 seconds extra to vote if you haven't already. Okay, that's good. I'm sure it could be worse. Yeah, okay. So I think we're all agreeing on the same thing, that it's not that bad. It could be worse. And I've seen a lot of suggestions on how to improve this, which is good. So you guys know like a good how to write a good code stack. So 43%, let's say, actually, let me share the results. 43% of you said that the code is poor, while 50%, 52% said that it's average, and 4% said it's very good. I wouldn't say it's very good. There are a lot of things that we can improve, and we're gonna see how to do that. But I agree with the majority is that it's average. The person who wrote this code at least took care of indentation. So at least you know what section of what is the scope of each section of the code. And the namings are not that bad. So it's not like the naming of the variables are I or J. It's actually something related to, for example, in this case, oops, let me just bring in my annotator. For example, in this case, it's something related to, oops, why is not moving? Weird. So related to intersection, for example. In this case, it's related to let long. So we know that what the variable might contain. I've never seen, I've seen non-indented code. Yes, I've seen a lot of non-indented code, especially in 244, and it is, it made my life so hard to actually look at the code. Anyways, so but now we agree that it's an average code. Let's see what we can improve in these. And I've seen a lot of suggestions that the code is clustered, it's too dense, and maybe the variables should be moved around. So let's see how we can actually do this. Let me actually move this in here so I can. Okay. So the first comment, as your colleague said, is that there are no vertical white spaces. The code is too dense in here, and you can see that everything is condensed within on each other. So it makes it hard to read actually the code. So what I would recommend is try to break the code into like paragraphs of related code or sections of related code. What do we mean by this? Basically, the first part of the code in here is corresponds to declaring variables. So keep it separate. The second part is basically an if statement. Also keep it separate. And inside the if statement, also keep different things separate. Like try to divide them into sections of related things. Okay. Actually, there is something I missed. Sorry, I'm trying to move the windows around so I can see everything. Yeah, I think Isidore, you are correct. We can actually do things on online, but we'll see if actually that's a good idea or not. The second thing that we should look for is try to minimize the scope of the variables or like the where the variables are declared. In this case, if you look at the, for example, this first, this slash, this second, or this, all of them are used only in the else. So it might be actually dangerous to declare them because there is a potential initialization box. Like you might actually initialize them here by mistake and use them later on, but you don't actually want that. Also, length, for example, is only used inside the first if statement. So why not move it there? So what we should do is move length inside and move these also inside the else to try and minimize the scope where the variables are declared. We should make the entire program one line. No, that's really not a good idea. That's hard to read. Yes, it's really hard to read. Okay, now let's look at the variable names. While I agree that the variables are a little bit descriptive, but some information but we lost some of the information due to the naming. So for example, we lost where the info.from and info.to go to, because now we only called them enter1 and enter2 and latlon1, latlon2. We don't know which one is from, which one is to. Okay. There are also some redundant variables that are temporary variables. For example, enter one and enter two do not add much to the clarity of the code. They can just be removed and we replace info.from and info.to in here, right? Also for length, we can just do a length return this at once. We don't have to define double length or just adding to the length of the function for no reason. Okay, so try to use as this names that are as descriptive as possible and avoid temporaries that do not add much to the clarity of the code. So let's improve our variable names. First, we will replace ID with street segment ID. Why is that? Because we might use ID for multiple things. An ID can be a street segment ID, it can be an intersection ID, it can be a feature ID, etc. So again, make it as descriptive as possible. Second, similar to info, you can use it, you can call it segment info instead of info to know what info is this about. Third, we removed basically the temporary variables that are not needed, enter one and enter two. They are not needed, and you can just replace segment.info.from and segment.info.to immediately at where you need them. Okay. And next, we can keep track of where the from and to are. We can basically rename the variables to position from and position to instead of latlon 1 and latlon 2. Okay. Next, there is also another temporary variable that is not needed, which is the length. And we can just say return find distance between 2 points. Okay. All good. So what about, so according to what Isidore said, these two also might be temporary and they are not needed, which I agree. It's very subjective. So, well, what do you think? Should we remove them or not? Are these considered redundant or not? Again, this is very subjective. So whatever your reason is, you can say why or why not. Okay, so some of you are saying keep them. They are self-documenting. I agree. Yeah. So removing them like this would make the code harder to read. Exactly. Like if you read this one line, a lot of things are happening on one line. So first we are trying to go into get intersection position twice, and then we are trying to do a find distance. So this is sometimes temporary variables improve the readability and add information. Because again, as you guys said, one line is very hard to read. And especially if you are trying to debug this one line, you will confuse yourself on the actual steps or sequential steps that are happening in the debugger. You will not know at which get intersection position call you are right now, for example. So are you in the dot from or the dot to? So it's better to always keep it's better in this case to have the temporary variables to keep track of the sequential steps of your code. Isidore saying my goal is to make the code hard enough that you need to be up to read it. If other people can understand it, then that's problematic, and that's why I make my point. Okay, sure. That contradicts the whole idea or whole motivation behind code stack. Okay, so we agree that to keep them. Now let's look at how the code was. It was very condensed. It's hard to read too many variables that are not needed. And this is how it looks after we've improved it, which is much better. The only thing that we should talk about yet, we haven't talked about yet, is comments. The code should be commented in well enough so that the reader understand what is happening. So we're going to talk about comments, but on a different example. In general, these are some of the guidelines that you should follow when thinking about comments, the do's and don'ts. What you should do is try and describe the overall structure of your program and data structure. So if you create a new data structure, for example, a vector of vectors or a map of something, just add one or two lines saying what is this data structure about. Don't mention details. Just try to like this data structure will help us improve the performance in that function, for example, and it will store this kind of data. For example, it will store the intersection as a key, and the street segments as a value, for example. Describe why design choices were made. For example, if you used a vector instead of an unordered map, say why you used a vector in this case. You might actually help the reader of the code get a deeper understanding of the code in this case. If you have a very complex algorithm or a very complicated algorithm, try and describe it in simple terms. Don't go into details. Just simply like let the reader know what this function is about. What you shouldn't do is you shouldn't leave commented out code in your project. So if you've changed something last minute, remember that all the changes are saved in your Git history. So you don't have to keep the commented out code. Just delete it and submit. Do not also translate code into English. So do not try and comment every single line and go into the details. This will not help the reader and will actually make your code more cluttered and hard to read. So try to avoid that. Okay. The other thing that you should look for is the duplicate code. If you have duplicate code in your code, that means it's dangerous because let's say that you're using the same, for example, 10 lines in a lot of places in your code. And then at some point you discover that there is a bug in those 10 lines somewhere. So either you will have to go and change the bug every single time where it's called, or you basically keep your code buggy. And this is obviously time consuming and error prone. The second thing is that it adds to the length of your function. So basically it will hinder the readability of your code. So whenever you see a duplicate code, try and extract it and remove it to basically a separate function where you can only call this function once. In this case, if you have a bug in that function, you will only change it once. And you will definitely shorten your code length by just adding one line instead of 10 lines every single time. So for example, in this example on the slide, I'm not going to go over the details what it's doing. It's basically trying to, in general, trying to make sure that a certain segment ID is not duplicate in our data structure. And you can see that in two cases, this code is exactly the same or almost the same. So why not extract it and move it to a separate function? Okay, let's call it insert unique. In this way, we basically shorten the code from around 12, 13 lines to only 2 lines. Let's look at the comments. What do you think of the comments in here? So we have basically 2 comments for each line. And basically, they are trying to describe what we are trying to do. Are these good comments or not? They are average. Okay. Again, this is very subjective. For me, I would say it could have fewer words. Exactly. It's a bit wordy and repetitive. Basically, they are both trying to describe the same thing, but for different inputs, which is not needed in this case. We can just replace them by, for example, one line, add street segments if it is not a duplicate. So now we understand that these 2 lines are just checking for the duplicate, right? It's more succinct, it's higher level, and it's described 2 lines at once. So it's simpler and improves the readability of the code. So I hope that you've grasped at least the idea of behind how to improve your code style. Just to remind you that always try to shorten the length of your code. Don't keep your code cluttered. And we've introduced some aspects of the code that can help you do this. Like try to do shorter functions, try to describe the variable and function names as much as possible, and limit the variable scope. Don't declare variables globally every time. And make sure that your comments are succinct, they describe what you are doing, they are not very detailed, so that they are simple. And finally, don't leave duplicate code. Just to, like, if you want to read more about code style and how to improve your code style, here are some of the resources. I definitely recommend this one. A lot of companies these days basically use this one, Google Style Guides. It's a little bit detailed, but it has a lot of things that might benefit you either in the project or in your career. So this basically the tutorial for today ends. If you haven't attended the first session, please stay on the line. If you have, I'm here for 5 minutes to answer any of your questions if you have. Otherwise, I'll see you hopefully next week. No problem. Anytime, guys.